All right, folks, we are looking at our next assignment. So in the workbook 522. All right, so it's 1 through 7. You know what? I'm going to just, again, give you strategies for this. I won't do all the problems because they're very similar. Now, if we look at this, we're investigating scale factor. We did that in the last lesson where, we had triangles and we were dilating it, enlargement, or reduction. Based on the scale factor, you would just have to apply it to each sides of a triangle, right, to make the triangle become larger or smaller. So for instance, if your scale factor was 2, you had a triangle. You know what, I can draw right here. Why not? So you had the triangle. That's not a drawing. That is. All right, let's just go back. Get out of here. Get out. All right, so if you have a triangle, it is a right triangle. Look at that. All right. Now, if the scale factor for this was 2, right? So let's say this was 5, right? 4, you may recognize this, and 3. Now, if my scale factor was 2, if it was a shape, it would be pretty easy. I would just multiply each side by 2, and we'd end up with a triangle with side length 6, 10, and 8, okay? Now, the same thing applies. If I'm using a scale factor here of 2, I take this side, 5, and I multiply it by 2. What do you think is going to happen here? Here we have a line segment, AB, equal to 2.25 units long. The segment is dilated by a scale factor of 3.2. So what do you think is going to happen to this line segment? It's 2.2 units long. We're going to make it larger. Okay. The K factor, or scale factor of K, is equal to 3.2. They use K for scale factor. So watch. All I got to do is this. No big deal. We go here and we take our 2.25. And I don't want you to write this out. I want you to go in here and make your line. It's really easy. You call this AB. No. We'll call this next week I'll have an actual touch screen. All right, so this was 2.25, right? Really easy to look at and see. Crap. You know what? I'm not going to do it. It's way harder to do it like this. You can go ahead and just, when you're doing this problem out, I do want you to show AB is 2.25, scale factor of 3.2, etc. So watch, 2.25 times 3.2. Could it be possible that answer is that easy? It is that easy. So 7.2 here is our new, watch, my points have to be like little circles. 7.2 for number 1. Okay. Now, is it going to change? Here, look, we have GH. It's this length. Here's our scale factor. Do you think it's going to change? No, it's not going to change. We have the length of GH. That's our pre-image. Our G prime H prime, our full image after the transformation, is going to be that 15.3 times 2/3. Okay. Looks like 3 and 4 are the same. Let's keep looking down here. Here we have HJK has the following vertices. All right, so we have these 3 vertices for this triangle. What are the vertices under a dilation with a center 0, 0 and a scale factor of 3? Okay, so I'm going to pause it for just one moment because I want to... Hello? All right, we're back recording here. I just set it up here on Desmos because I wanted to look at this. And I look at this, determine the image vertices of each dilation given a center. The center is important, and the scale factor. Okay, so if I look at this, for number 5, we have H, J, and K. And what I did here was, now we have to, one more thing here. It's always going to be about the center, honestly. What are the vertices under a dilation with a center of 0, 0? Scale factor of 3. Okay, so what I did was, look here. I want to move this, please. Thank you. All right, so what I have here is I have my H, I have my J, and I have my K. And if we kind of zoom in a little bit. Now, if I want to look at this, it is a dilation. If we look back, it's a dilation with a center of 0, 0. Now, the main thing with this is it's going to point out that the expansion and enlargement is going to go from 0, 0. So it's going to enlarge in this direction. So I better move over a little bit, okay? It's going to enlarge in this direction. And again, here's the thing. Just like up here, how we had the line segments here, and we had a scale factor that we multiplied it by, it's going to be the same thing down here. So here we have a point. It is this distance, right? -7 to the left, -2 down from 0. The point is actually denoting the distance from 0, okay? Now, if I have a scale factor of 3, what's going to happen to these values? I'm going to go ahead and end up with a point that's -7 times 3, which is -21. And I'm going to end up with a point -2 times 3, that's -6. Let's go ahead and label this. Let's label this H prime, okay? Whoops, H prime, just the one apostrophe, okay? Let's see where this ends up. It looks like we got to zoom out a little bit more. All right, you see? So the center is 0. So this point here, H and H prime are a factor of 3 away from 0. Okay, so like if this is 1, if we look, we can see 1, 2, 3. But you don't even have to think that abstractly. You can look at this and just say, okay, well, we had H is -7, -2, so H prime is going to be -21, -7 if we have that scale factor of 3. So let's do another. Hey, come on. How about another? All right, let's go ahead and do what happens with this point J. J is here at -5, -6. Scale factor of 3 is going to put that at what? -15, -18, right? We just multiplied by 3. I want to label that. I'm going to label it J prime. See where that ends up. Look, it's way down here. Now let's look. The center is 0. Here's the distance from 0 to J, from the origin 0, 0 to J. And we look, and it's about 3 distances away to get to J prime. So it is 3 times the distance from 0 as J is, okay? And finally, let's see what we got for the last one. If I have K right here, K is -6, -8. We have a scale factor of 3, so we're going to end up with -18 and -24. And we're going to label that K prime. All right, let's see where that ends up. K prime is going to be a little bit further down. There you are. Okay, now let's look. You could see the shape of the triangle here, right? HJK and HJK down here. It is 3 times larger, right? It's 3 times larger, these distances. You could see the center is 0, so you can almost see like it's projected out. If I were to connect these dots between, it would look like a 3-dimensional triangle coming out at you, okay? So in a lot of ways, perspective, drawing in perspective is related to dilations because it has that center point, right? This would be, what is it when you're doing different, like 2-point perspective? It's like the focus point, right? Because these all these line up to 0. They all point back to 0, okay? So that's basically what I wanted to look at for this problem here, number 5. And if we look here, PQR has these points. It has a scale factor. Center is 0. It's going to be the same process. Here, MNO has these points. It's dilated from 0. Scale factor is 75%. So instead of multiplying by 3, we'd multiply by, what's this as a decimal? 0.75. Okay? I think this lesson is actually very doable. We're going to go ahead and stop there. That is all the homework that you guys have assigned. So I want you to go ahead and complete that. I'm going to hold on doing a quiz this week because people are still getting into the class. But make sure that you are doing all this homework. This homework from the workbook will not be collected, but during the quiz, I will have you note how many you've done. Honor system, you got to do it. Also, I will point out that on the back end of Edmodo, so this is my period 5, I can see how many energy points you guys have accumulated each day. Okay, so that's what I'm watching as far as to see if you're engaged. And if you have a 0 for too long, I'm going to call you up or message you somehow. Okay, I'm going to bug you. All right, that's it. Hope you guys are all doing well, and drop into office hours if you need me to go over into these more in depth. And also next week, again, I will have my tablet, so I'll be able to do more like Khan Academy videos, not this the cheap whiteboard thing I've been using. All right, guys. Take care. Bye.